This week's objective is I can divide using partial quotients. For a little bit of background information on division, you may want to look at the last YouTube video posted on what is division. That'll give you some background information and some skills you need to know first. Partial quotients may seem familiar from 4th grade where you learned it called lucky 7, but we like to call it partial quotients because there's really nothing lucky about it, it's just math. It also will look quite familiar to partial products, which we use for multiplication. There's another YouTube video on that as well. So when we talk about partial quotients, what we're saying is we're going to find pieces of our quotient, because we know that a quotient is the answer to a division problem. And so we're kind of trying to find pieces of it and break it into smaller manageable parts to solve. I'm just going to jump right into it. So right here, if we have this problem that is labeled 25,416 divided by 4. Real quick, I know that this first number right here is my dividend. The number that I'm dividing by is my divisor, and I'm looking for my quotient, which is my answer. The first thing that I'm always going to do is set this up with my division symbol so that it's easier to look at and work with. Make sure that looks like a comma and not like a decimal. The next thing that you do is you extend your division sign down, and here's where the name Lucky 7 comes from, because it looks like a 7 now. What I would suggest you do next is make a sort of toolbox. I know that the divisor I'm working with is a 4, meaning for this problem right here, I need to access all information I have on dividing by 4, or really, because of inverse operations, multiplying by 4. So over here, I'm going to make a quick little toolbox of some math facts of multiplying with 4. Probably by 2, 3, 4, 5, 6, 7, 8, 9. Now, if you already know your math facts, the toolbox might not be necessary. It might just be something that you know off the top of your head, which is fabulous. But if you don't know your math facts, use your toolbox and just write your math facts down real quick. 4 times 2, 8. 4 times 3, 12. 4 times 4, 16. 4 times 5, 20. 4 times 6, 24. 4 times 7, 28. 4 times 8, 32. 4 times 9, 36. There's some basic facts. Now that you have these math facts written off to the side, it's important that you can think about them in the bigger picture. For example, if I know that 4 times 4 is 16, I also need to be thinking in my head that 4 times 400 is going to give me 1,600. And I need to be able to think about that with all of these numbers. 4 times 7 is 28, so that must mean that 4 times 7 is 280. 4 times 700 is 2,800. Having all of that information in your brain is what will help you solve with partial quotients. Now, my first step when I look at this, partial quotients, is I use my knowledge of inverse operations. I say, okay, I need to figure out what my dividend divided by my divisor equals using multiplication facts. So the first thing I do is I look at my entire number, my entire dividend, 25,416, and I say, using math facts of what I can multiply 4 by, what factors I can use, what number can I multiply 4 by that will get me the closest to 25,416 without going over? What I like to do is I look at the whole number and say, okay, I have 25,416. Then I look at maybe the first 1 or 2 numbers. If I look at the first number, can 4 go evenly into 2 with any math fact? No, it can't. So I'm going to look at the next 2 numbers. And there I have 25. I look over at my toolbox and I say, what multiplied by 4 will get me the closest to 25 without going over? If I look down, right here. 4 times 6 gives me 24. That's the closest I can go without going over. I might check the next factor up just to make sure I can't go one higher. But 4 times 7 gives me 28, and that would go over my 25, so I don't want to use 4 times 7. I want to use 4 times 6. With that information, I say, well, I know that 4 times 7 is 28, but 4 times 6 is 24, but I don't just want 24, I want 24,000. So I say, okay, applying my understanding of powers of 10, what power of 10 can I multiply 4 by to get me closer to 24,000? Well, in 24, there are going to be 1, 2, 3 zeros, which means I need to multiply 4 not by 6, but by 6,000. 4 times 6 gives me 24, with 1, 2, 3 zeros, 24,000. So to put that into my partial quotient structure, I come off to the side and I say, okay, 4 multiplied by 6,000 gives me 24,000. This 24,000 is now my partial dividend, and this 6,000 is part of my partial quotient. To move on and continue, I say, okay, I can subtract this 24,000 and see what part of my dividend I'm still left with. 6 subtract 0. I now have 1,416. And I start the process over again. I say, okay, what can I multiply 14 by that will get me the 4 by, that will get me the closest to 1,416? If I look at the first digit in my dividend, 1, there's nothing that I can multiply that will get me close to 1 without going over. So I look at 14. If I look over here at my partial quotients, I can see that, oh, yeah, multiplying 4 by 3 will get me 12, which is pretty close to 14 without going over. And if I check my next fact up, 4 times 4 is 16, that would put me over, so I know for sure that 4 times 3 is the fact that I want to use. I'm going to use the same basic process, applying properties of multiplying by 10, to figure out what my partial quotient needs to be here. Because I say, okay, I need to use 4 times some power of 3 in a format. So I say, okay, I actually need it to be not just 12, but 1,200. So that means I need 100 times greater of an answer, which means I need 100 times greater of a factor of 300. I check. 4 times 3 is 12 with those 2 zeros. Yeah, 4 times 300 is 1,200. So I write my partial dividend on the inside and my partial quotient I used of 300 off to the side. Then I can subtract and figure out where my dividend is at now. 6 subtract 0, 6, 1, and 2. Now my dividend is down to 216, and I repeat the process all over again. I say, okay, is there anything I can multiply 4 by that will get me close to 200? 216. Well, yeah, there is, because I know that 4 times 5 gives me 20, and that 20 is pretty close to 216 if I use my powers of 10 in saying 4 times 5 might give me 20, but if I want my answer to be around 200, I'm going to want to multiply by 50 and say 4 times 50, well, 4 times 5 gives me 20. Place that 1 0, 200. So over here I say my next partial dividend is 200, and the way that I got that 200 was by multiplying by 50. So I write my partial quotient off to the side. I subtract to see what part of my dividend I'm left with. I now have 16 left, and I ask the exact same question. What can I multiply 4 by that will get me close to 16? Well, this one should be a pretty simple math fact because all I have to do is multiply it by a single digit factor. 4 times 4 gives me 16. So off to the side I say, great, my last partial quotient is 4. 16, if I subtract 16, subtract 16, I'm left with 0. I know that I am done in the division problem when my dividend, my partial dividend, has reached a point where it is either 0 or a number that is less than my factor. If I have a number that is less than my factor, that means I have a remainder or something left over after I've split into equal sized groups. If I'm left with 0, it means my divisor was able to go into my dividend evenly without any numbers left over, which is where I'm at right now. My last step in this process is to say, okay, I have all of these partial quotients. In order to determine what my final quotient is, I simply need to add them together. We have to remember again when we're adding that we have to line up based on place value. So I have 6,000 plus 300 plus 50 plus 4. If I add together the digits in my ones place, I'm left with 4. In my tens place, 5. My hundreds place, 3. My thousands place, 6. My final quotient is 6,354. The best way to check my division work is to use inverse operations or multiplication. If I did my work properly, then I should be able to multiply my divisor by my quotient to equal my dividend. If I use the standard algorithm to check that, if I take 6,354 and multiply it by my divisor, which was 4, I should get my dividend. 4 times 4, 16. 4 times 5 is 20, plus 1 is 21. 4 times 3 is 12, plus 2 is 14. 4 times 6 is 24, plus 1 is 25. My product is 25,416, which if I double check, that's the same thing as my dividend, and that tells me that I did my work correctly and my answer is fine. Once you can use partial quotients to divide, you can move on to even using it with story problems, such as if I spent every day for a week working shoveling snow, was paid the same amount every day, and by the end of the week made $4,375, how much should I make each day? I can then use partial quotients to solve problems such as this. For now, the big things that you need to remember with partial quotients is your math facts and how those relate to multiplying by factors that are 10 times larger, 100 times larger using your powers of 10, and also for now using your toolbox. You might get to a point where you don't need it, but for now I would definitely rely on that.